Hey guys, happy Wednesday. So today we're talking more about graphing inequalities and determining solutions to inequalities. So yesterday we talked about just graphing them, and I kind of want to review stuff that we've talked about. So things we've learned. We've learned that less than sign means a dashed line, and it also means that we are going to shade below. Then we talked about greater than sign. That is also, it's a bad sign. There we go. This is also going to have a dashed line. And we are going to shade above. Then we talked about less than or equal to. This is going to be our solid line, and we're going to shade below. And then we talked about greater than or equal to. Again, it's solid line because of that equal sign, and we're going to shade above this time because it's greater than. So that's kind of what we've talked about. We also talked about putting it in slope-intercept form, solving inequalities to get y equals mx plus b. When we do that, we have to, if we divide or multiply by a negative, that inequality sign flips. Today we're talking about solutions. What is a solution to an inequality? So what you're going to do is you're going to plug in a point by hand into your inequality, and if it is true, if what you plug in comes out and it is a true statement, then it is a solution. If it is a false statement, it is not a solution. So let's look at number 1. So again, it gives me a point. Remember, points are given in x comma y. So I'm going to plug in my x value everywhere I see an x, and I'm going to plug in my y value everywhere I see a y. So I've got 3 plus 2 is greater than 5. And then I add these up. 5 is greater than 5. Is 5 greater than 5? No, 5 is equal to. So if it were greater than or equal to, it would be good. But 5 is not greater than 5. So no, not a solution. So that's kind of how you do it. So again, if I look at this guy, points are given x comma y. I'm going to plug in a 5 this time everywhere I see an x in my inequality. And then I'm going to plug in a 3 everywhere I see a y in my inequality. So I've got 5 minus 3 is greater than or equal to 2. 5 minus 3 is 2, greater than or equal to 2. Well, yeah, 2 is equal to 2. It's not greater than, but it is equal to. Remember how we say this? We say greater than or equal to. So it doesn't have to be both. It's one or the other. It's either greater than or equal to, and it is equal to. So this checks out. Yes. It is a solution. So that one checks out. That one's good to go. 3 again. X and Y coordinates here. I'm plugging in this time a negative 2 everywhere I see an X. Oops. And I'm plugging in a negative 3 everywhere I see a Y. So I've got negative times negative 2 minus 2 times negative 3 is greater than or equal to 5. Well, negative times negative 2 is just a positive 2. Negative 2 times negative 3 is positive 6 is greater than or equal to 5. 2 plus 6 is 8. And 8 is greater than 5. So this works. Yes. That one works. Okay, let's try. Oop, that's all those. Okay. So by a graph, if I'm given a graph and I ask you, let's say I don't give you the actual inequality, what you're going to do is by graph, the solution is in the shaded area. It could also be on the line, but only if the line is solid. If it is a dashed line, this is a no-go. If it is dashed, it's a no-go. It's an awful D. Okay, And the reason for this is, the only reason it's a solution if it's in the shaded area, anywhere in the shaded area, or if it's on a solid line, not a dashed line. And this is because lines are solid if they are equal points on the line make it equal. So if it's equal to, that means it's going to lie on that solid line. So only if it's in that shaded region, or again on the dashed line. So let's look at some examples with the graphs. If we look at number 4, my m, again, is whatever number is next to my x, which is a 1. I've got 1x. And my b is by itself. That's the -2. This is going to be a dashed line because there's no equal to, and it's greater than, so I'm shading above. And again, they already graphed it for me. How nice are they? It's asking, can solutions be on the line? Which of these are solutions? So first off, can solutions be on the line if I plot a point on there? No, because it's a dashed line. If it were solid, yes, they could be on the line, but since it's dashed, it's a no-go. Which of these are solutions? So -2, 2. I'm going to go over -2 and up +2. It is in the shaded region, so that's a go. We're going to circle that guy. He's good. Then I've got 4, 5. Over 1, 2, 3, 4, up 1, 2, 3, 4, 5. He is in the solid, so he's a go. Over 3, 1, 2, 3, down -1. That doesn't work. It is not in the shaded area. Over 0, down 1, 2. This is directly on that line. They cannot be on the line, so this is a no-go. Over 1, up 1, in the shaded area. Over -2, down 1, 2, 3, 4, 5, 6, 7. Again, not in the shaded area, so that's a no-go. So those 3 points are the only ones that are solutions to that line. This one, they don't give us the picture, so we're going to have to draw the picture ourselves. So again, my m is whatever's next to my x. In this case, it is 1/2, 1 over 2. My b is by itself. It's over here. It's a +3. The sign is going to be dashed because there's no equal to. And I'm going to shade below because it's less than. Let's get to graphing. So I start with my b. That's my beginning. I'm going up +3 on my y-axis, and I'm going up 1 over 2, up 1 over 2, up 1 over 2. Or I could go down 1 to the left 2, down 1 to the left 2, down 1 to the left 2. Again, I'm making this a dashed line. Then I look at where I'm shading below. So I'm going all underneath this line and shading. Okay, it is a dash, so can solutions be on the line? No. Which of these are solutions? So let's plot these and see which ones we think are solutions. So -2, up 2. That is on the line, and we said we can't have it on the line, so that's no. Over 4, 4, up 5, 1, 2, 4, 5. Again, that is on the line. So that one is a no-go. 3, -1. Over 3, down 1. That is in our shaded area, so that one's good. Over 0, down 2. In the shaded area, that's good. Over 1, up 1. In the shaded area. -2, -7. 5, 6, 7. In the shaded area. So those 4 are solutions, the rest are not. Let's look at this guy. Already solved for us. So I'm looking at what's next to my x, which is a 2. So my slope is 2. My b is by itself, so that's our plus 1 over here. I look at what the sign is. It has an equal sign, so it's a solid line, and it's less than, so I shade below. So let's get to graphing this guy. I start at positive 1, and I'm going up 2 over 1. Up 2 over 1, up 2 over 1, or I could go down 2 to the left 1. Solid line, so it's going to be straight all the way through. And then I'm shading below. Okay, this is a solid line this time, so can solutions be on the line? Yes, because on solid, that's possible. On dashed, it's not because they are not equal to. It cannot be equal to solutions on that line. So which of these are solutions? Negative 2, 2. So I go over negative 2, up 2. It is not in the shaded area or on the line, so that one's a no-go. Over 4, 2, 3, 4, up 1, 2, 3, 4, 5. It is in the shaded area. That one's a yes. Over 3, down negative 1, 2, 3, negative 1. Again, in the shaded area. 0, negative 2 is good. 1, 1 is good. Negative 2. 1, 2, 3, 4, 5, 6, 7 is also in the shaded area. So the only one that's not a solution is that negative 2, 2. Okay. Then let's look at this last examples here. 7 says, an ice cream truck can carry at most 75 gallons of ice cream. The table shows the inventory on the truck. Write an inequality that represents the number of gallons of strawberry and banana ice cream on the truck. Strawberry and banana ice cream on the truck. Okay. So on the truck, I can have at most 75. So whatever's on the truck has to be less than or equal to 75. But I've got to add up all of these ice creams and figure out what my X and what my Y can be. So I've got to add my vanilla plus my chocolate plus my strawberry plus my banana plus my sherbet. Right? Then I can also combine like terms. So, oops. I can add 20, 15, and 18 all together. And when I do that, I should get x plus y plus 53 is less than or equal to 75. And it asked me, could there be 12 gallons of strawberry and 13 gallons of banana? So strawberry is my x, and banana is my y. So we're going to plug in what we know. So I know everywhere I see an x, I'm putting in 12, and everywhere I see a y, I'm putting in 13. So I've got, oops, 12 plus 13 plus 53 has to be less than or equal to 75. And I end up getting 78 is less than or equal to 75, which is not true. So this would be no. This does not work out. Okay, determine two possible solutions to the inequality. And this one would be anything in the shaded region. Anything in shaded region or on the line because it's a solid line. Any of those would be solutions. Okay, this one says complete the linear equality that represents a relationship shown in the table. So what I would do is I'd start plugging in some points and figure out what's happening when I plug them in. So I've got y something 2x. So if I plug in my first point of negative 3, and my negative 8 is here, 2 times negative 3, and again I'm using this point here, I've got -8, and then over here I've got -6. Well, I know -8 is less than -6, so right now I'm thinking it's a less than sign. We might have to change it to an equal to, but we'll see. So then if I try the next one, I've got -10, 2 times -2, -10, -4, again, -10 is less than -4. So I'm still sticking with my gut here. I'll do another one just to make sure. I've got -2.5 and 2 times -1, -2.5 and -2, again, less than. This one I've got 0 and 2 times 0. 0 and 0. Well, these are equal to. So some of them are less than and some of them are equal to. So I do need to change this to a less than. So that's how you would do those. You would just plug in. And I would plug in a couple just to make sure there's not an equal to, or if you got an equal to, make sure if it's less than or greater than. So I would say at least 3 or 4 points just to double check and make sure everything works out okay. So I would plug in less than or equal to on that one. And I think that's it on that. So that's all you're doing today is determining solutions. You do have homework in Google Classroom. If you go to Google Classroom, go down to graphing lines and inequalities. Today's Wednesday, November 4th. So when I go down here, you have a Google form to complete. Again, I think it's like 10 questions. This one, the first 4 are just asking you, is this point a solution? So you plug in your X, plug in your Y, just like the first examples we did on the notes, and tell me yes or no. This one gives you a picture and you're telling me which ones are solutions, so you can check all that apply. There's going to be more than one, so you're going to check all that apply are in the shaded area or on the line. Again, a word problem. Here's your points, 5, 7, and 8, 2. You're plugging in to see if that works. This is just like the example we just did. So 7 and 8 are just like the example we just did. You're going to have to plug in points and figure out the sign. And then 9 and 10 are review questions. They're just solving equations. You can use Desmos or you can solve them by hand. And that's your homework. Bye, y'all. Have a great day.